Welcome to this tutorial using the Scikit machine learning tool. Today, we're looking at a multi-class, multivariable classification problem solved with a random forest classifier. Our case study is based on a hypertension dataset. Over the next few slides, I'll walk through the dataset, the features we use, the target we want to predict, and how random forests help us train and evaluate the model. Here we see a summary of the columns in the hypertension dataset. These include demographic information like age, lifestyle indicators such as salt intake, exercise, and smoking status, as well as clinical measures including BMI, blood pressure history, and family history of hypertension. Each of these columns is an input feature that contributes to the predicting a patient's hypertension status. This slide highlights the structure of the hypertension classification dataset. The dataset has both input features, all of the columns we just reviewed, and the target variable, which is the hypertension classification outcome. This column is encoded into integer data. It was originally the string dataset. 0 means no hypertension. 1 means prehypertensive, and 2 means hypertensive. Now we explain the classification model, the random forest classifier. A random forest classifier is an ensemble of decision trees, each trained on the bootstrapped sample of patients and features. Each tree learns its own rules, and when making predictions, the final class is chosen by the majority vote across the trees. This reduces overfitting and improves accuracy. The mathematical expression at the bottom shows this voting process, where each tree gives a prediction and the model outputs the most common result. In this example, the input features are the patient's characteristics like age, BMI, cholesterol, and so on, while the output feature is the hypertension category. Finally, we train and evaluate the model. We split the dataset 80% for training and 20% for testing. After training, we evaluate the model using the F1 score, which is a balanced metric combining precision and recall. This is important in healthcare because both false positives and false negatives can be problematic. The workflow is straightforward. Train the random forest, make decisions on the new dataset, and then evaluate its performance. Now let's move on to how to use our Scikit machine learning tool web app to implement this gradient boosting classification model on the hypertension dataset. First, let's give our project a name, and then let's write a brief description of our project. And then in the data type drop-down list, let's choose the tabular data type because our data is in the CSV format. And then let's click upload CSV, and then let's click this upload button to upload our dataset. So after successfully uploading the dataset, we will see a brief summary of our dataset. The summary table lists all of the columns of our dataset, and the data tab shows node instances of our dataset, data type summary of our dataset, and unique value summaries of our dataset. Now let's move to pre-processing step and choose our target label, which is the hypertension column. And then let's choose our machine learning algorithm. We choose our random forest classifier, and then let's choose our F1 metric, and then click perform. We can see our evaluation result. F1 score is 0.96, which means our model was able to very accurately predict the result based on our input features. Thanks for watching.